In this video, we're going to talk about these two special triangles, namely the 45-45-90 and the 30-60-90. These triangles come up frequently in math, and they are often part of the SAT examination. The first thing I want you to notice as you look to the triangle on your left is that because these angles are equal, that means these sides that are opposite are also equal. So whatever length you have here, it's going to be the same on this side. On the right, with the 30-60-90, notice that the length opposite the smallest angle, namely the 30 degree, is shorter than any of the others, and the side opposite the 90, namely the hypotenuse, is the longest, and the 60 degree is somewhere in the middle. Now folks, I'm going to give you some reference values, and unfortunately you're going to have to memorize these. But once you memorize these reference values, I assure you these problems will be easy to handle. On the left side, the 45-45-90 has these reference values, and on the right you're going to have these reference values. Okay, so notice, again, on the triangle on your left, because these angles are equal, these sides are equal. And on the right, the side opposite the 30 is the smallest. Square root of 3 is about 1.7. And the side opposite the 90 degree angle is the largest. Now, the other thing I want you to notice is the fact that this is a 1, that's a 1. That's a 1. The fact that this is a 1 lets us move from the length of this side to the hypotenuse using this as a conversion factor. And you'll see what that means in a minute. On the right side, the fact this is a 1 opposite the 30 degree angle means we can move from the side opposite the 30 to the side opposite the 90 using 2 as a conversion factor, and we can move from the side opposite the 30 to the side opposite the 60 using the square root of 3 as a conversion factor. What we cannot do is move from the side opposite the 60 to the side opposite the 90 because there's no 1 here, and you will see what that means in a moment. So what I'm going to do is I'm going to leave this reference diagram on the screen for at least a few of the problems, and then we're going to remove it and go without it. So I think you could still see that there. Let's move to the first problem. Okay, what they're going to do is they're going to give you a triangle, they're going to give you an angle, and they're going to give you one of the sides, and they're going to ask you to find the other side. First thing you do is you recognize that this is indeed a 45-45-90 degree right triangle, which means by definition this has to be 45 and these two sides have to be the same. So the question is, what is the hypotenuse? So what you do is you say to yourself, okay, I am moving from the side opposite the 45. We have that value, that's 8. And I'm moving to the hypotenuse, which is the side opposite the 90 degrees. Okay, so let's call that x. So we're moving from this to there. Now as we move from this side to the hypotenuse, we're getting bigger by definition because this line is shorter than that line. So if we're getting bigger, we have to be multiplying. And what do we multiply by? This conversion factor, square root of 2. So as we move from 45 to 90, this is going to become 8 times the square root of 2. Okay, let's do another one. Okay. This is a 30, 60, 90 degree triangle. If this is 30 and that's 90, this has to be 60. Okay. Now, we are trying to find the side opposite the 60 and the side opposite the 90. We already have the side that's opposite the 30, and we know that value is 5 right here. So let's first move to the side that's opposite the 90 degree. We come here to our reference triangle. Okay, the side opposite the 90 has a conversion factor of 2. So let me write that in there. The question now is, as we move from the side that's opposite the 30, which is here, to the side that's opposite the 90, are we getting bigger or smaller? Answer is we're getting bigger because this length is longer. Therefore, we have to be multiplying by 2. So that value is going to be 10. Now, let's go from the 30 degree to the 60 degree. Okay, again, the side opposite the 30 degree is 5. We're going to use square root of 3 as a conversion factor. And because we're getting bigger, we're going to multiply. So those are your two answers. Side opposite the 90 is going to be 10. And this is going to be 5 times the square root of 3. And again, we used square root of 3 when we went from 30 to 60 because that's the conversion factor associated with the side opposite the 60 degree triangle. Let's do another one. Okay, so this is a 45, 45, 90 degree triangle, and we're asked to find the other sides. We know these sides are going to be the same. We have the side that's opposite the 90 degrees. We have that. We're trying to find the side opposite the 45 degree. Okay, so let's write the value that we have. Now, what's the conversion factor when you're working with a 45, 45, 90 degree triangle and you're moving from a smaller side to a larger side? It's square root of 2. Actually, the conversion factor is always the square root of 2, whether you're going from big to small or small to larger. Okay, now we ask ourselves, as we're moving from a 90 degree, side opposite a 90 degree, to a side opposite a 45 degree, are we going to get bigger or smaller? The answer is smaller. That means we have to divide by the conversion factor. That's how we get smaller, ladies and gentlemen. We divide. If you have the number 4 and you divide by 2, that's 2. That's smaller. The way we get bigger is we multiply. 4 times 2 is 8. This got bigger. Okay. So here, when we divide by the square root of 2, these cancel out, and the final answer is 6. And I encourage you to pause the video after I write down the problem and try these on your own. That's the best way to learn. Okay, so what do we have here? We have a 30, 60, 90 degree triangle. The side opposite the 30 degree we have whenever you're dealing with the 60 degree angle on the side opposite, the conversion factor is going to be square root of 3. Okay. We already have this value. So we ask ourselves, as we're moving from the side opposite the 30 to the side opposite to the 60, are we going to get bigger or smaller? The answer is we're going to get bigger. Therefore, we multiply by the conversion factor. Now, when you multiply two radicals, as long as the root is the same, we can just rewrite the factor out front, rewrite the radical sign, and just rewrite the factors. So this becomes 12 times the square root of 9, which equals 12 times 3, which equals 36. That's not degrees, I'm sorry. Okay, so again, to review, we have the side opposite the 30 degree. We're trying to find the side opposite the 60 degree. Our reference triangle says that whenever 60 degree is involved, we're going to use this as a conversion factor. We place it here. We're getting bigger, therefore we're going to use that conversion factor to multiply, and that is our final answer. Now, how do we go from 30 to 90? Again, we have that side opposite the square root of 3. The conversion factor, whenever you're dealing with the side opposite the 90 degree, is going to be 2 in a 30, 60, 90 triangle. I'm going to put that conversion factor there. When I move from the side opposite the 30 to the side opposite the 90, I'm going to get bigger. Therefore, I'm going to multiply by the conversion factor, and the final answer is going to be 24 root 3. I'm going to do a couple more, and then I'm going to remove those reference triangles. Okay. How about this one? Okay. What do we have? We have the side that's opposite the 90 degree. Remember, you can only work from the 90 degree to the side opposite the 30 degree, or from the 30 degree opposite the 60 degree. In other words, we cannot move from 90 degree to 60 or 60 to 90 because there's not a 1 in either of those conversion factors. So whenever we have 90 or 60, we have to move to 30 first. Okay. When you're in a 30, 60, 90 triangle and the 90 degree is involved, that's the conversion factor. Put it here. We ask ourselves, when we move from the side opposite the 90 to the side opposite the 30, are we getting bigger or smaller? We're getting smaller. Therefore, we have to divide by the conversion factor, and that's your final answer. So this is going to be 8 root 3. Now that we have the side that's opposite the 30 degree, now we can move to the 60 degree. Okay, so here we're going to go 30 to 60. We have this one. The conversion factor when you're dealing with 60 degrees is always going to be the square root of 3. The only question is, are we going to divide or multiply? We're getting bigger as we move from this side to that side, therefore we're going to multiply. Okay, let's keep going. Okay. We have a length. They give us one of these angles. That's 90. This has to be 60. So what do we have? We have the side that's opposite the 60-degree angle. We have to go to 30. We cannot go to 90. Whenever the 60-degree is involved, square root of 3 is your factor. The only question is, do we divide or we multiply? Well, we're getting smaller. Therefore, we have to divide. Now, folks, whenever you have a radical in the denominator, you can't quit there. You have to keep going. And specifically, you have to multiply by that. Now notice, the square root of 3 over the square root of 3 is just 1. So all we did was multiply this by 1. Perfectly legal. Whenever the denominator equals the numerator, that's 1. So watch what happens when you do this. On the bottom, you're going to get square root of 3 times 3, which equals the square root of 9, which equals 3. So that's how you get rid of that radical sign. You multiply it by itself. You create a perfect square under a radical sign, namely 9. Square root of 9 is 3. Now, what about the top? Pretty straightforward. It's just going to be 9 square root of 3 over 3, and then you can cancel that out, and your final answer is 3 root 3. Okay, now we have the side opposite the 30 degree. It's 3 root 3. Let me write that in there. The question is, what is the side opposite the 90 degree? Okay, so we're going to go from the 30 degree to the 90 degree. We have this. The factor is always 2. When you're dealing with 90 degrees in a 30, 60, 90 triangle, there's your conversion factor. The only question is, are you getting bigger, therefore you're going to multiply, or do you divide? Well, we're getting bigger. So we're going to multiply 3 root 3 times the conversion factor, and that's going to give us 6 root 3. Okay, time to get rid of what's in the upper right corner and try to do these problems now without the aid of that drawing. Okay. How would you handle this one? Okay, if that's 45, that has to be 45. And if the side opposite the 45 is 2 root 2, then this has to be 2 root 2. The only question is, what is on the side opposite the 90 degrees? So we are going to go from 45 to 90. And the conversion factor is always the square root of 2. We have this value. The question is, what are we going to do with this conversion factor as we move from 45 to 90? We're getting bigger, therefore we're going to multiply. This front factor stays the same. We're allowed to rewrite the square root sign and multiply what's underneath the two radicals. And we end up with 2 times 2 equals 4. So that's your final answer for that hypotenuse. Next one. Sorry. Okay, so what do we have here? If that's 60 and that's 90, this has to be 30. They give us the side opposite the 90, so we have that. And that's 16. We have to go to 30 first. Whenever you're dealing with the 90 degrees in a 30, 60, 90 triangle, the conversion factor is 2. The only question is, do we multiply or divide by the conversion factor? Since we're getting smaller, we have to divide. That's how we get smaller in math. So that's 8. So the side opposite the 30 is 8. We have that. Now we're going to go from the 30 to the 60. Whenever 60 degrees is involved, that's the conversion factor. We have this. The only question is, what are we going to do with this conversion factor? Well, we're getting bigger. If we're getting bigger, we have to divide. So that's your final answer. There's your complete triangle. We have a 45-degree triangle. That makes this 45. That makes this and this equal. Excuse me. The question is, what's the value? They give us the side opposite the 90. There's your conversion factor. They give us that. We're getting smaller. Therefore, we have to divide by the conversion factor. We cannot leave the square root of 2 in the denominator. We multiply. Again, this just becomes the square root of 4, and that simplifies to 2. So here's your final answer for the hypotenuse. Okay, we have a 30, 60, 90. I'm going to write the 60 in there. They give us the side opposite the 30 degrees. Let's go to the 90 degrees first. The conversion factor is 2. We're getting bigger as we move from this side to that side, so we're going to multiply. Now we're going to go from the 30 degree to the 60. Our conversion factor is square root of 3. We have this value, they gave it to us. Are we getting bigger or smaller? We're getting bigger. Therefore, that's your final answer. $45.90, this has to be 45. This has to be 3 root 2 because they're both the same. So if they give us the 45 degree, we have to find the 90 degree. There's your conversion factor. Are we getting bigger or smaller? We're getting bigger. Therefore, we have to multiply these two. This factor stays the same. This becomes the square root of 2 times 2. Again, as long as this root is the same, you can rewrite the radical and multiply what's inside. This becomes 3 square root of 4, 3 times 2 equals 6. Okay. The fact that that's a 60 means this has to be 30. What did they give us? They gave us the side opposite the 90. We have to work with 30 degrees. What is the factor? 2. Are we getting bigger or smaller? We're getting smaller. We have to divide. Now that we have the side opposite the 30 degree, we can go to the 60 degree. Conversion factor, square root of 3. We have this value, bigger or smaller? Bigger. Therefore, we have to multiply. That's your final answer. Okay, let's do one more. And let's do the 30, 60, 90. They're a little harder. The fact that that's 30 and that's 90, excuse me, this has to be 60. So they gave us the 60. We have to work with 30. What's the conversion factor whenever square root of 3 is involved? Are we getting bigger or smaller? We're getting smaller. That means we're going to divide by the conversion factor. We cannot leave the radical sign in the denominator. Okay, we now have the side opposite the 30 degree. Now that we have that, okay, now we can go 30 degrees to 90 degrees. What is the conversion factor? 2. Are we getting bigger or smaller? We're getting bigger. Therefore, we're going to multiply by this conversion factor and get 8 square root of 3.